So let's talk in a little more detail about AT&T switched Ethernet. Remember, this is a layer 2 service, and in the context of our 7-layer OSI model, that's the Open Systems Interconnection model, layer 2 falls right in the middle of sort of the most important 3 layers for us, the bottom 3. In fact, we're not even going to concern ourselves with the top 4, and fortunately the bottom 3 are pretty easy to understand. The first layer, the physical layer, that's just cables, the copper cables, fiber optic cables, and we transmit either pulses of electricity or pulses of light down those cables, and that's it, just wires that connect our networks. Layer 2, the data link layer, is where local area networks live, LANs. All of the computers in an office might be attached to a switch, and that would be our LAN. By the time we get to layer 3, we're dealing with IP addresses and routers, and like my home network has a router that all of my LAN stuff is connected to, and my router could talk to a router in China, and behind that router is some guy's LAN. So that's what routers do. They sort of define the edges of networks. Let's go into more detail about each of these briefly, and it's important to understand Ethernet. But let's just pretend you had a battery and you connected the positive terminal of that battery to one of the wires in a cable, and you did the same with a negative terminal, attach it to a wire in the cable. You would have made a circuit. And let's pretend you held the blue wire to the negative terminal of the battery for 1 second, and then you removed it for 1 second and put it back on for 1 second, kind of alternated like that once every second. You'd essentially be transmitting data down that cable, offs and ons and ones and zeros. That's how we transmit data, at least on copper cables, high voltages and low voltages that represent zeros and ones. And whatever's at the other end of that cable is going to be receiving that data. And just as a matter of fact, you'd be transmitting that data at a rate of 1 bit per second, because I told you that's what you're doing. 1 BPS is pretty slow and impractical, and you'd actually never connect a battery to a cable, but you could. But instead of attaching a battery, let's attach a laptop, a little more typical use case. And we're going to use that laptop to send an email to our friend Alexander. Like all other data, an email is made up of ones and zeros, and our laptop is going to be the thing that sends those ones and zeros down our cable. It's important to note that before our data reaches a switch or a router, it's living on layer 1 only. So it's important to understand what layer 1 is. Again, just cables. So here's a switch. It's like the front of a switch. That's what the picture is. By the time our data gets here, it's crossed into layer 2 territory. Like I said, every device in a local area network communicates within layer 2, very often by being connected to a switch. And you can imagine a different computer attached to each one of these switch ports here. So I can't just send data out blindly. It has to have an address to know where to go. And we use 2 different types of addresses. One, on layer 2, we use media access control addresses, MAC addresses. And for layer 3, we use IP addresses, Internet Protocol addresses. It's just important that you know the difference and can make the distinction between those 2. Just for fun, here is my computer's MAC and IP address that I pulled just a couple of seconds ago and highlighted for you, just to demonstrate that there's nothing to it. Every computer has a MAC address, and every computer is assigned an IP address by its router. Just for fun that you know that. But here are my 2 addresses, and they're just strings of numbers in different formats. So along with the email data that I'm sending Alexander, I'm also sending his MAC address and IP address along with that data, so the email data knows where to go. For now, let's not worry about how I got those addresses. There is a process for that, but you don't really need to concern yourself with it. So the switch that we're connected to, as well as all good switches, it keeps an up-to-date table about which MAC addresses are associated with which ports on that switch. And if the switch that we're connected to in this example knows where Alexander's MAC address is, it's going to send our data out that port, out the port where it knows the MAC address lives. So let's just see if we can find Alexander's MAC address. No, unfortunately not. It appears that this switch only knows about guys with 3-letter names, MAC addresses. So does that mean our data is not going to get to Alexander? Well, no, because we have another port, we'll call it other, that's connected to, in this case, a router. And that router will know about other LANs. So even if Alexander is not on our local area network, he's on somebody else's local area network, and that router is going to go find it. So, again, make a note here, as long as our data stays, on switches only, and it can go to other switches, it might hit 2 or 3 before it gets to a router. As long as it stays on layer 2, or as long as it stays within switches, it's on layer 2, and it's perfectly reasonable that I might get to my end destination on layer 2 only. It just didn't pan out that way in this example. So let's go hit the router. You can see the LAN and WAN designations for each one of my ports. We just came from LAN. Everything else is connected out the WAN, and Alexander's somewhere out there in the big wide world. So again, we talked about how routers are edge devices. They define the networks behind them. In this case, the LAN is what I'm talking about. That's what's behind us. Ahead of us is the WAN, the rest of the world. Let's follow that cable. Let's take a quick diversion to say routers just don't care about MAC addresses. They don't even look at them. They only care about layer 3 addresses, which IP is what they use, Internet Protocol. And all a router knows about are the layer 3 IP addresses of other routers that control other networks. In reality, my data leaving my house right now is going to my ISP, my Internet Service Provider, and that data is going to go over many routers before it gets to, hopefully, its end destination. But I just wanted to take a second out and say our data is still traversing all 3 layers up to this point. We've gone through 1, 2, and 3. We're going to live on 3 until we get to our Alexander's router in this case, and then it's going to go back the other way down the OSI model, 3, 2, and 1, down to copper. So let's keep going. My router is connected to essentially the internet. That's everything else in the world. And it's important to note that carriers such as AT&T contribute a large part of all the infrastructure that connects devices that essentially becomes the internet. Another example of what I've done here on my computers in the past couple of minutes, I did a trace route to google.com. That command in Windows basically finds all the routers between me and whatever router Google is going to use ultimately to get me to its data. So you see it started at my home router, went through a bunch of Time Warner cable routers, so that's my ISP at home, and Time Warner handed it off to yet another carrier who I've never heard of, and it got all the way to Google's router in Dallas-Fort Worth area. It took 16 router hops to get there, but of course when you go to google.com, you don't really notice any delay. You can see 1 millisecond, 13 milliseconds, 20 milliseconds. Those are all the delays between each of the routers, so pretty quick. It's impressive, but our data is going quite a long way across a lot of devices. And again, this is just to give you a broader picture of what it means to kind of do layer 3 networking. All right. So the tech behind us now, let's talk about a real case study, Gonzales ISD. This is a school district in Gonzales, Texas, of course, that has 4 full-time campus techs, 350 faculty members, and about 4,500 students. We're going to show you what Gonzales looked like before a solution. It was really just 6 randomly connected metro campuses. There's Gonzales. You can see, we'll zoom in a second, but there are the 6 campuses roughly positioned correctly in the city. And let's start with Gonzales Junior High just to zoom in. You see all these little numbers with arrows. On our network diagrams, that represents, each set of arrows represents a switch. I have 10 of these switches. So this campus LAN is connected together by 10 layer 2 switches. You see the blue cables connecting each one of them. That represents the connection between each of them. You see some are connected all back to one, which is the main switch in this case, the main switch closet. Some are just connected through others, which are connected to one. So it just kind of makes sense with the geographical layout of this campus. Let's look then at the connections between each of the campuses, of which there are 6. You got 5 schools and 1 central office where the administrators and all of the really heavy networking equipment like, file servers live. Here is how Gonzalez's campuses were connected before. They had an intercampus WAN. So I talked about how WAN could mean the rest of the world. Well, it could also mean just everything that's not my LAN, but not necessarily the rest of the world. They had a WAN because each of their campuses had a router, a layer 3 router. And that means they're not all in the same network, which is, it's not terrible, but it's sometimes not ideal if you're trying to share data. We don't want to involve routers unless we have to. So there are some funny things about this kind of intercampus connection scheme that we'll get into in a second. But first, let's talk about the internet connections. There are 2, which is the first funny thing. Central office is attached to the internet. That's the main connection to the internet. But so is Gonzalez High School. Why? Well, because the traffic was too slow at Gonzalez High School. It had to go through Gonzalez Elementary, East Avenue, those 2 campuses to get to central office out to the internet. So yeah, it's slow, and for a lot of other reasons, it was a little buggy. So here are some of the problems with this network. The fiber infrastructure is old. I mean, that just happened to be the case. They laid it in the 90s. So old fiber deteriorates. It breaks. It doesn't work as well as it used to. You'll notice right here between Gonzalez Elementary and East Avenue Primary, man, I hope that cable doesn't break because there are 3 campuses behind, East Avenue Primary. If I can't get to one of them, I can't get to any of them. So single points of failure. This is not a very redundant network based on its topology, based on the cabling, the layer 1, physical infrastructure that's connecting them. It just so happens that because this is a WAN and not a LAN, I have kind of unnecessarily complex layer 3 routing. I mean, it's not like these are different companies or different school districts. It's all the same school district. It doesn't need to be different on different networks. I mean, it could be, but it's, again, unnecessarily complex. We could achieve this with a pure layer 2 network and never have to enter into layer 3. Like I said, 2 network connections means wasteful spending. I get why they do it if they have this sort of topology that we see in orange, because there's too much risk of failure if I don't have 2 in this case, but it's unnecessary. And kind of in the same vein, it's complicated to manage my network. Again, it's a layer 3 network. It takes routing tables and routers instead of just one single network, as though it were a big version of a big office. It's hard to manage 6 different networks, harder to manage 6 different networks than one network. So let's talk about Gonzalez after the solution. 6 campuses and 1 metro LAN, and metro just meaning sort of driving distance, local area here. This is all within a few miles. It's a small town. So we see, again, the solution before. Here is the switched Ethernet solution superimposed. And by the way, this doesn't mean we dig up the old fiber. It still works well enough to be a redundant backup link. But now, instead of having sort of random interconnections between campuses, all of my campuses are connected back to AT&T's network. AT&T's network is much more reliable than 20-year-old fiber because AT&T, of course, maintains its network more thoroughly than you could expect 4 campus techs to. Because each of these campuses is connected to kind of that central hub, we call this a multi-point connection. It's not point to point to point in a ring. Everything's connected to everything, essentially. It's like an any-to-any connection. And in this way, if one link goes down, I have other links that can take its place. And in addition to that, oh, by the way, the internet doesn't need to be at 2 different places in this scenario. You can just think of the internet as an extension of AT&T's network, to which we're also connected. And that means all of our campuses effectively share the same connection equitably with an easily controlled sort of bandwidth management scenario set up. The benefits here compared to the previous scenario are we have a clean, flat, unified network topology. If you removed kind of the old fiber, just look how much cleaner that is. I don't have some random division between Gonzales Elementary and Gonzales High School and North Avenue Intermediate. You can see how this makes a lot more sense. I have point-to-point connections between each of my campuses and the hub between, I still have my existing fiber. It's a cleaner topology. I have centralized network management if I so choose. That means central office can use one campus tech to effectively administer the entire, district of campuses because it's one network. There aren't 6 networks anymore. I've minimized my risk of failure, again, because AT&T's pipes, AT&T's cables, its layer 1 infrastructure is just going to be more robust than, a school district's. Talked about increased redundancy already. Talked about how I combine my internet usage, but I also, there are lots of servers that live in central office. That's kind of what it is from an IT standpoint. It's the warehouse for everything tech. I have data servers, financial servers, attendance servers, all kinds of servers. And now, instead of having to take weird routes to get to central office, I'm taking the most direct route, which is through AT&T's pipes. And finally, again, to cap it all off, I'm using simple layer 2 Ethernet. There's no need to have routers. Routers are great. Every network needs one, but you don't need 6 if you can help it. So let's look at what this service might cost in this scenario. AT&T switched Ethernet is the product. Our speed is 100 megabits per second in this case. By the way, the entire school district was only using 50 megs for the internet connection. So I'm doubling that to make sure I have enough room for other things like, sharing data that's coming from central office but not necessarily going to the internet. So I have some overhead above my internet connection speed. Contract term of 3 years because this is a school district. They think in bigger terms than other organizations. My cost per site in this case, my cost per campus is $974 per month. And for 6 sites, that's $5,844 a month, or about $70K per year. So that's the solution cost. Pretty reasonable considering they can cut back on IT staff. They can cut back on administrative breakage, sort of when things break and you have to, put down everything you were doing before, like, getting the iPads ready to go and go fix the network instead. It makes a more efficient network. It really is a cost-saving thing. Often when we start to talk about how we can help customers implement newer networks, bigger networks, we're not just selling them more features. We're selling them cost savings over the way they're conducting business currently. So the bigger networks get, the more we can help. I guess that's the point to take away. All right, so we talked about the 7-layer OSI model. I just want to come back to it briefly and say it's just a way that we think about networks. It's a conceptualization kind of aid. And again, all you really need to worry about is 1, 2, and 3, cables, switches, and routers. Of all the AT&T network products that we're selling, 1, 2, and 3, layers 1, 2, and 3 are all that are really affected and all that you really need to know about if you need to know anything. So that's switched Ethernet. That's an application in Gonzales ISD.